Hello, everyone. It is my pleasure to welcome you here today to this informative webinar, which aims to provide you with a clear understanding of the Impress project. I start to introduce myself. I'm Regina Ciancio. I'm the Impress project coordinator, and it is my true pleasure to introduce the other speakers from today from the coordination team, Rafal Dunin-Borkowski, who is the Impress Scientific Coordinator, Amir Tavabi, who is the Impress Technical Coordinator, and Stephan Corvers, Senior Procurement Expert, who is the representative of Corvers, key partner within Impress with the specific scope to help us with the pre-commercial procurement procedure. Indeed, today, beyond a general overview of the project, the purpose is exactly to drive you toward a comprehensive understanding of the pre-commercial procurement procedure, which is actually the backbone of Impress and the innovative means through which the project aims to generate a paradigm shift in TM instrumentation. In particular, the intent is to give you details on the open market consultation phase we are facing at the moment, which is a preparatory activity of the PCP progress that we will launch in the next November. So, looking at the agenda of today, after a general introduction of the project, I will leave the floor to Stephan Corvers, who will introduce to you about all the details of the pre-commercial procurement. Then Amir Tavabi will follow with a presentation on the technical insight of the PCP procedure we are setting within Impress. And in the end, Rafal Dunin-Borkowski will have a presentation on the initial user and bidder feedback we started to collect in this preparatory phase. So, as I said, I will start with a general overview on the Impress project, where I will try to give you a quick overview on the overall contents of the project, its objectives, and overall strategy. So let's start with a general ID card of the project. Well, Impress stands for Interoperable Electron Microscopy Platform for Advanced Research and Services. Actually, in this acronym, you can already identify the two main roots of our strategy, interoperable and services, the two main keywords which are at the basis of our rationale that you will discover in the next slides. Impress started officially on February 2023 with a timeline of 4 years ahead until 2027. It was submitted within a specific funding scheme of Horizon Europe, the Horizon Research and Innovation Actions, and specifically under the Infratech call, which has a specific scope to award the project able to deliver research and development for the next generation of scientific instrumentation tools and methods. Well, as an electron microscopy community strongly motivated to apply to this call, we immediately discovered what big challenge we had ahead, and specifically the ambitious objectives that we had to pursue. In practice, we were asked to find the best strategy to address the next generation of TM instrumentation. Before getting into the details of our strategy, of course, we need to have clear which is the background that we had to consider. Well, over the latest years, the expansion of a TM installation around the world has been enormous. The number of TMs has increased a lot, and in most of the cases, this has brought to duplication of electron microscopy columns, and in most of the cases, these are related to very specialized applications or niche applications. This increase of installations has brought us to a crucial bottleneck. Actually, what we are facing at the moment is a duplication of efforts, a duplication of upfront and running costs of these costly machines, which are raising considerable concerns on sustainability of these research installations. Actually, it is widely recognized that the TM market is propelled by innovation and especially by instrumentation developments. And as of today, instrumentation developments driven by a diversified user experience are recognized to be winning imperatives. So with this in mind, we decide how to address our strategy and especially how to move towards a new TM area. It is clear that a disruptive technological step change is needed today at the TM facilities with a specific mandate to provide, to develop the specialized methodological techniques able to cross all scientific domains and expand the current field of electron microscopy applications. Of course, this put high demands on advanced TM infrastructures, which are asked to offer a flexible combination of state-of-the-art techniques in fully interoperable experimental arrangements. We are then back to our keyword, interoperability, which in our case does not only apply to open data, data sharing, and data handling, but interoperability also refers to hardware and instrumentation with the need specifically for standardized and interconnected methods. Of course, in this scenario, open innovation and co-creation are specific keywords to establish and reinforce the dialogue between companies and electron microscopy scientists in order to overcome technical challenges that cannot be solved by the electron microscopy market alone. This means that developments have to be designed in order to provide user communities with optimal and flexible services to perform innovative experiments. Only in such a way, electron microscopists can develop and transfer the latest technologies efficiently across the landscape of TM facilities, cooperating scientific infrastructures and specialized laboratories. But let's see what is in practice the IMPRESS missions. With this in mind and following along these lines, of course, IMPRESS set a specific strategy to move towards a new TM area, making TMs flexible to a diversity of multimodal experiments rather than adapting experiments to TMs. This means that the scope is to provide users with the possibility to plan and design an experiment, ideally from a bench, to transfer it to TMs, but also to other instrumentation, including synchrotron techniques. But let's see how IMPRESS declines its strategy, and especially underlying what IMPRESS aims to reach. IMPRESS aims to co-develop and deliver advanced transmission electron microscopy instrumentation methods and tools which are conceived at the highest level of open standards and interoperability. This is with a specific target in mind, to deliver customized components which are compatible with different sections of an electron microscopy column and can be moved across different columns from different manufacturers, that can be integrated with other instrumentation in all sectors of applications. So all this to have TMs flexible and adaptable to a diversity of multimodal experiments, with the ultimate objective to create the first open knowledge and innovation hub for TM. To reach these objectives, Impress brings together 19 partners distributed across the European landscape, coming from 6 research and technology organizations, 5 universities, 5 research infrastructures, and 3 small and medium enterprises. Here you can see the breakdown of the partners distributed into the mentioned relevant sectors. But let's see how Impress aims to reach these objectives. Well, the core of the project is the co-development of an interoperable platform based on interchangeable components that can be readily customized by the users from different scientific communities and according to their needs. As you can see here, TM is at the core, but as I said before, users are at the core of this strategy. So all the components have to be designed in order to provide users with the possibility to span across a wide platform of different techniques, from sample preparation techniques to surface techniques to synchrotron techniques. How this will be pursued? Actually, the interoperable platform consists of interchangeable and modular hardware and software components which are based on a standardized cartridge concept which we named ECAT, where E stands for electrons and CAT stands for correlative, adaptable, and transferable. So users will be given the opportunity to design and carry out a correlative experiment that can be easily transferred from one instrument to the other one, from TMs to other instrumentations, and vice versa. The cartridges are designed to be adaptable in order to satisfy the requirements of the users coming from different scientific domains. They are going to be designed also to be modular and transferable between the different planes and segments of an electron microscope, microscopes from different manufacturers, and also to be adapted to different instrumentation. Here you can get a flavor of the general ECAT modular concept. You can see how the device will be versatile and flexible in order to move interchangeably between the sample plane, the aperture plane within the electron microscope, and also designed to fit with other instrumentation. In particular, as you can see on the right, according to a cartridge within cartridge concept, the device can be easily adapted to the different openings of the different sides of the microscope. In addition, the device will be designed in order to host as many functionalities as possible, from electrical contacts, cooling, liquid, heating, any kind of requirement in order to be multifunctional and multimodular. Of course, the project will also include other contents and other developments, going from electron sources with enhanced beam properties and electron optical performances, adaptive optics and detectors for advanced imaging spectroscopy, different sample environments for in situ and in operando application under different stimuli, software based on artificial intelligence methods for simulation capabilities and automation of experiments. All these innovative developments will be integrated with the new cartridge-based platform in order to make them available to users. But let's see how Impress will pursue these scopes. And here we are at the core of the content of the event of today. Indeed, Impress will set a specific instrument to reach its scope, which is the pre-commercial procurement, or PCP. Indeed, we talked about co-development. We talked about companies. The PCP is the special instrument through which Impress will set a special dialogue with companies. PCP is indeed a demand-driven approach supported by the European Commission to foster research and development services and stimulate the development of innovative solutions to address societal challenges. Through the PCP, selected companies will be indeed involved in a competitive development process, which is composed of 3 phases: a solution design, a prototype implementation phase, and a validation and demonstration phase. What is important to keep in mind is that the PCP is nothing so different from a tendering process, but with a specific difference. The PCP is not going to select just one winner at the end, but to set a synergistic platform where different companies can compete and win the tendering process, each company bringing a different expertise. This has as a final aim to set a synergistic dialogue with the scientists in order to deliver the prototypes with the targeted functionalities foreseen by Impress. This joint effort between companies, scientists, and users will lead to the effective co-creation of the Impress innovation ecosystem. Through the PCP, winning companies will have the opportunity to compete within this special scheme and to address global markets and attract external investment and business opportunities. Here you can see the PCP organization. 7 Impress partners will contribute and will participate and will be strongly involved in the PCP procedure, with FZJ as a lead procurer, since the PCP will be executed under the German law. Legal support is provided by the consultancy firm and project partner Corvers, and you will have more details about the procedure by Stephan Corvers in the next presentation. Another added value which brings innovation within Impress is that with our project, we will set the first open knowledge and innovation hub for transmission electron microscopy. Indeed, we will set the first archive where all data, metadata, but also technological and technical data will be stored and will be made openly accessible. In such a way, we will raise our fair approach to the 3rd dimension by merging together the 3 main strategic assets: fair data, fair technology, fair documentation. All this will be performed in full compliance with the European Open Science Cloud ecosystem. Let's summarize the project structure that you can see here and drawn in order to recall the geometry of the ATM column. We have 7 different work packages, and beyond the work package number 1, which will be devoted to the coordination and daily operation of the project, and will also deal with the data management plan, IPR regulation, we will have 5 scientific work packages. Work package number 2 will focus on and will lead the PCP procedure that will support the competitive design of the interoperable platform. The work package will also define the technical requirements and the optimization of hardware and software solutions that will be obtained through the PCP. Work package number 3 will be dedicated to the development of electron sources with enhanced brightness, emittance, and flexibility for imaging and spectroscopy purposes. Within work package number 4, new electron detectors will be developed with a special emphasis on novel electron phase shaping technologies to improve the quality of the information retrieved. Work package number 5 will be dedicated to the development of multifunctional chips with specialized capabilities for different in situ and in operando applications in order to set correlative workflows embracing different characterization techniques from TEM to also synchrotron techniques. Then within work package number 6, digital technologies for fair data management will be created with a special attention on software control system, machine learning approaches, and artificial intelligence. All this will be supported by a thorough communication and dissemination plan, including training activities with the scope to train the staff to the new prototypes that will be delivered. Actually, you now have all the ingredients to understand the unique co-creation value chain that Impress will be able to put in place. Well, the interoperable platform will be the overarching concept and basic concept which will be underlying all the project activities. The prototypes will be developed through the different phases of the pre-commercial procurement, and they will be strongly interlinked with the project contents, therefore linking with the development of sources, adaptive optics and detectors, and in situ operando and correlative applications. Of course, all this will be strongly interconnected with a software platform dedicated to digital technologies. As we said before, the keywords remain co-development, co-creation, and all this will be possible thanks to the strong interaction between electron microscopy scientists, companies, and the constant feedback from users that will be conveyed to us through the involvement of the research infrastructures which are part of the consortium. The added value to innovation will be that everything will be shared in the FAIR Cube in order to make available all the results to the communities having access to this archive. At the end of the project, we are we will be supported, of course, by an advisory board which will support us constantly in order to address and readdress the scopes of the project, and a careful training program will allow us to train the staff and also users to the new prototypes that we will be delivering. At the end of the project, by the end of the project, we are expected to deliver at least 8 prototype cartridges and associated technologies through the PCP procedures, and make them available to the project partners for experiments to be also carried out with the users operating at the participating research infrastructures. To conclude, Impress will reach the ambitious goal to deliver advanced instrumentation, TM instrumentation, tools and methods that are conceived to be interoperable, adaptable, and accessible and user-friendly thanks to specific keywords, open standards to ensure compatibility and facilitate integration with analytical tools, open components to allow the creation of customized TM instrumentation and experimental arrangements based on open interface to allow for interoperability and for a seamless exchange of components and data between different TM's instruments and also other instrumentation, and based on open knowledge to boost sharing, drive innovation, and promote progress. With this, I conclude my presentation. I thank you for your attention, and I leave the word to Stephan Corvers for his presentation.
Thank you. My name is Stephan Corvers, and I'm founder and CEO of Corvers Procurement Services. We're based in the Netherlands and in Greece. And the topic of my presentation is on pre-commercial procurement, which is a unique tendering process in the EU. My agenda for my presentation is as follows. First, I'm going to give you some introduction on the concept of pre-commercial procurement, or PCP, what it stands for. I will give some introduction on the action plan for Impress PCP, and also what is intended with the Open Market Consultation and related timelines for that. First, on the concept of pre-commercial procurement, PCP. PCP falls in the concept of innovation procurement, and innovation procurement consists of two components. One is PCP and the other one is PPI. PCP stands for pre-commercial procurement and PPI stands for the public procurement of innovative solutions. And innovation procurement happens when public buyers require the development. Innovation procurement happens when public buyers acquire development or deployment of pioneering innovative solutions to address specific mid to long-term public sector needs. And what you see here in the concept of pre-commercial procurement is really about the procurement of R&D services. And the public procurement of innovative solutions, PPI, is more about the procurement of existing solutions, technologies, and related services, but not so much about R&D services. And the concept of pre-commercial procurement is as follows. I will go into that a little bit later. It is about a phase approach from phase 1 to phase 2 to phase 3, and it's about competitive development in each and every phase. So the idea is that you start, for example, with 4 or 5 technology vendors, and you end phase 3 with 2 technology vendors on the concept of may the best win. And the reason why the EU has set up this scheme in such a way and has not chosen for a scheme in which you only end with 1 technology vendor is that you would like to avoid a certain lock-in for the follow-up PPI. So for this process, we're talking about PCP, the procurement of R&D services. The PCP is needed when you have come as a public authority or contracting authority, as we say it in Europe. If you come to the conclusion that no solutions are already available on the market that fulfill your needs. So you have done your preparatory activities, you have done your SWOT analysis, you looked into what the market can offer, you have come to the conclusion that what you want is not available yet. And then there's room for this approach, for this PCP approach. And of course, the R&D is then needed to identify an innovative solution to satisfy your needs as a public body. The PCP is characterized by the competitive development in phases, from phase 1 to phase 2 to phase 3. It is also based upon a risk-benefit sharing between on the marketing conditions, and there's a clear separation between the procurement of the R&D from the deployment of commercial volumes of end products, which is called the PPI. And to frame it more in the context of the TRLs, the pre-commercial procurement is really somewhere between TRL 3 and TRL 8, but does not include TRL 9. Now a little bit about the legal framework. The PCP concept is relatively new in Europe. It started in 2007 with a communication from the European Commission, Pre-Commercial Procurement, driving innovation to ensure sustainable, high-quality public services in Europe. And it has been strengthened by the procurement directives of 2014 and 2040 framework for state aid for RD&I. I think that there's also important to understand that the pre-commercial procurement falls outside the scope of the European public procurement directives. However, it does not fall outside the scope of the principles of the EU treaty. So that means that if you're setting up such a scheme, you always have to comply with transparency, you have to tackle equal treatment, non-discrimination, and proportionality. So you see all these kind of principles being translated into the tender documents and the approaches for this tendering process. What is then the action plan for Impress PCP? As it has already been explained, we will have different phases from solution design to prototype implementation and phase 3 for validation and demonstration. We intend to have phase 1 executed from March to June 2024. Phase 2, the prototype implementation for 2024, from August 2024 to January. Phase 3 from April to September 2025. In the first phase, we're going to have 4 or 5 technology vendors, perhaps more depending on the quality of the proposals that we're going to receive. But now, for now, we can say that there will be 4. For phase 2, there will be 3 technology vendors, and for phase 3, we're going to end up with 2 technology vendors. The budget is 2 million euros in total, meaning that for phase 1, overall, we're going to have a maximum budget of 300,000 euros. For phase 2, a maximum of 1.2 million euros, and for phase 3, a maximum of 500,000 euros. So per technology vendor, that goes from 75,000 to 400,000 to 250,000 as a maximum for each technology vendor to whom the contract has been awarded to. Of course, it can be so that during the execution of the PCP, there will be some modifications of differentiations, but for now, this is the rule that you can make countdown. Where are we now? We are now actually talking about August. We are actually in the preparatory phase for the tendering process itself. The preparatory phase ends around September, October of this year, and we intend to publish the contract notice and the tender documents per November of this year. And what you see in the preparatory phase on the left side, we have done our preparatory activities of designing and also exploring our needs. We have done a desk research on the market analysis. We have done a SOTA analysis. And that's also what we would like to hear from you, is if our preliminary findings are correct, or that we're missing something, or that you would like to give some feedback on some other elements. And that's why we're going to start, and why we're having the open market consultation, and the event in Düsseldorf is going to be the first formal event for that. And now we're doing, with this webinar, you will have already some background information on the PCP and the underlying rationale. Once the open market consultation has been finished, so that will be around the end of September, we will do an analysis based on your feedback. Your feedback is really appreciated, because we also see that that's going to be a success factor for the tendering process itself. We will do our business analysis and value case analysis, fine-tune our strategy, or our procurement and testing strategy, and then that will all be translated into tender documents to be issued by November of this year. Once we have set out the tendering process, started the tendering process, that will end around February of next year, when we start with the evaluation And also come to the contract award notice that will end around February, March. And the idea is that we start in March 24 with our phase 1 and the end, what I already explained, in September 2025. And I think for the PCP process, that's it. Of course, there's also an integration validation from that ends until January 2027, but the procurement process itself ends in September 2025. We are discussing PCP pre-commercial procurement from an EU perspective. And what you can imagine is that we also want to favor EU R&D. And not only we, also that is the concept of the PCP in the EU context. So what does it mean, favoring EU R&D? That means that the majority of the location of the R&D itself should be done in EU member states or the EU associated countries, which also includes the mandatory aspect to have principal researchers working on the premises in these member states for the PCP contracts in particular. It is not 100%, so it is a majority. The other element that is crucial for implementing PCP is that, but that's more from a legal perspective, is that the value of the total amount of products covered by the contract must be less than 50% of the total value of the PCP framework agreement. That means that the value of the R&D services should be higher than the value of the products, for example, the hardware. The favoring EU R&D is not only one of the main goals that we would like to achieve. The other goal is, as has already been explained, is we would like to favor an open hardware and software approach. For hardware, meaning that design specification should be licensed to allow the object to be studied, modified, created, and distributed by anyone. The software, the source code should be made publicly available on an open source license. And one of the well, I think all really exciting elements of our project is that we're going to establish the first open knowledge and innovation hub for TEM. It's called the FairCube. That's the accessible repository on open rules. Of course, Impress is aligned with the implementation of the European Open Science Cloud ecosystem and it's making Impress data services interoperable with ASOCs once. The API source code and the API documentation, as well as the GUI source code and GUI documentation, should be deposited in the GitHub community. Looking at the details, but you can find that, of course, in the tender documents in starting per November. The API license should allow redistribution and commercial as in the Creative Commons license family. Ideally, it should also allow creation and distribution of derivative works. The backend of the API is, of course, different. That can be closed source as long as it allows unrestricted use through the Open API. The GUI should be open source, again, for unrestricted interfaces with closed source and open source software by the user and third parties. And the license for the GUI documentation should, again, allow redistribution and commercial use in the sense of the Creative Commons license family. Another important aspect to consider is that we are going to exclude companies that are established in countries not eligible to participate in Horizon Europe innovation actions in any capacity. We are also going to restrict access to companies from the GPA WTO members. So I think it goes without saying, but we're not going to allow Russian companies to participate in this project and process. What is extremely important, what we all also want to encourage, and we also hope to receive feedback from you on that aspect, is that we see a strong possibility to form alliances of companies. So companies that can have a complementary aspect, startups, SME, also big companies, multinationals that would like to create big consortium or smaller consortia. That's it's all going to be well received, and you also will find that in the details about that in the tender documents. What phase are we now? We are now in the open market consultation. And I don't know if you know the concept of an open market consultation, but it is really a concept to interact and to engage with the market. So between the contracting authorities and public bodies on one side, and another side with the market and the technology vendors. And why is that so important? Because the open market consultation from a legal perspective, but also from a business perspective, gives us more flexibility to interact with the market than once we have started the formal procurement and tendering process itself. That is then the interactions are far more restricted. In an open market consultation, we have the possibility not only, of course, to create awareness, what we want, what we'd like to achieve, but also to receive feedback from you on our initial plans and timelines and whatever it is. We really would like to check our findings with you to see if we have missed something or if you have done something completely wrong. Of course, that's also possible. And with your feedback that we're going to receive, we're going to analyze that and translate that into the tender documents. Perhaps it goes without saying, but the information that we're going to receive from you is going to be treated confidential and is going to be anonymized if you're going to use that. That it goes without saying, but just to give you some comfort in that. Of course, we have to deal with all kinds of principles, so that's why it's called an open market consultation or a closed market consultation, so transparency is clear. Of course, we're going to have an efficient planning. I think we have a very strict and challenging time schedule ahead, not only for us, but also for you. But on the other hand, we see that we also have a unique project. It is a first pan-European project that has been set up in this way in this sector, and it gives also the possibility for you, of course, to speed up the developments that you already want to do. Not to forget that you also have the possibility to be engaged with the top procurers and the top research institutes in Europe. We're going to guarantee security of confidential information, treat state secrets and intellectual property. I already mentioned that. That goes without saying, but that's of course important. And again, we will ensure that we anonymize all the information that we're going to receive from you. We're not going to distribute the information as such to anyone else. Once the open market consultation has been closed and we have received your feedback, we're going to publish and disseminate the findings. Not so much the analysis, because I don't think that we have time for that, but really to give you an overview of the answers that we received on the questions that we have asked you and the answers that we have given to you on the questions you have raised to us. So we're going to publish and disseminate the findings by the end of September. And to give you an overview of the indicative timetable, well, the process started in July the 1st with the publication of so-called prior information notice, called a PIN in EU terms. And the OMC formally will start with of course, with the OMC event, the hybrid meeting in Düsseldorf in Germany, and it ends in September the 30th. And we try to come to a conclusion of our findings per the end of September, so per the 28th of September. So this again is indicative, but to give you an idea about the time schedule that we try to achieve. Another date that's going to be important for you is the publication of the OMC documents on the project website. The website is impress.eu. There you can find all the relevant material. We're also using for the questionnaires so-called EU survey documents from the European Commission. So you can answer the questions or you can ask your questions quite easily in this EU survey document, but referrals also in that OMC document, and also we'll give you the referral later on. So August, very important date to take into account. September, we're going to have the hybrid meeting. The deadline for questions is September 17th, and then we publish our findings by the end of September, and then the OMC is closed. And then we have a month or so to analyze everything and to translate the findings into the tender documents, which will be published in November. So, what we want from you. You are really invited to get in touch with us via an OMC questionnaire available on the survey. You find here the findings for that and the QR code. The Q&A will be published in OMC findings and on the Impress website. And we really hope that we receive a lot of feedback and we have a great interaction with you in order to hopefully that you're also going to be part in the upcoming tendering process for the PCP for our unique pan-European project. And with that, I would like to close my presentation and thank you very much for your attention.
Thank you, Stephan, for this great presentation. I will go immediately to Amir Tavabi's presentation on technical insights on the Impress PCP. Amir, introduce yourself briefly.
Yes. Hello, everyone. My name is Amir Tavabi from Gulish. I'm the technical coordinator of the Impress project. And I will try to give you some insights about the technical aspects of the PCP within the Impress. So you have heard a little bit about the PCP and what we are going to do within the Impress project from Regina and Stephan talks. In principle, we would like to develop an interoperable platform for TEMs, not only a single microscope within this procedure. And we will be dealing with all administrative, legal, and financial preparation and management of this development. We will test all the prototypes, which I will explain about the details of these prototypes in my talk within the Impress, and we will even approach more further technical development for these prototypes with this aim to reach the possibilities for novel experimental methodologies, which has not possible in the community at the moment. You're get information about the project structure and the work packages inside the project. What here I want to emphasize on is about the interdisciplinarities and the interconnections between the work packages. So as you know, the work package 2, which will be responsible and in charge of development of the interoperable platform within the PCP procedure, with dealing with all technical work packages 3, 4, 5, which are covering all segments of the microscope and different type of experimental workflows. And we will have a great support from an expert team on software, automation, and remote control who are dealing with the operation of the developed platform to be used in different experiments in TM and other analytical techniques. So this interdisciplinary and interconnection between the work packages here is quite an important issue so that we can move between different regimes. I know you might have seen the Impress procedure. I'm not going to repeat again the details here. However, the very critical point that I should emphasize here In phase two, we would have the implementation of the prototype. This will happen in Forschungszentrum Jülich. So all contractor, as I should say, at this phase two would deliver the prototypes to the Forschungszentrum Jülich. We will test them in Jülich and validate them, and then we will, after the evaluation and validation, we will get into the phase three for the real application, not real, for further application in different labs in Europe, including microscopy labs and other labs like synchrotrons. And this is a big difference between phase two and phase three. The phase two will happen only in Forschungszentrum Jülich. But when we are talking about the interoperable platform, in fact, what we are talking about? We know that different microscope columns has different geometrical aspects, has different dimensions. Sample holders, aperture holders are different. The number of the ports in the microscope in different segments are different. Some of them you might have one or two ports in a single plane, or maybe you are quite limited with the ports even in a same plane. The aim is to develop a device like a that I will explain quite a lot about this, like a cartridge in a cartridge solution, and then which would be interoperable between the different segment of columns in a single microscope. So not only in a sample position, but also in different planes, like before and after the specimen. And this platform can be moved in the same environment with the identical sample condition to another TEM, and further, and even further in the third phase to other uh, analytical disciplines. The two key aspects of interoperable platform, based on my explanation, can be summarized in these two terms: a standardized interface and cartridge-in-cartridge solution. What do we mean with a standardized interface? We would like to have different capabilities to running different type of experiments. At the moment in TEM community, we would have different holders, for example, gas, liquid, biosync holders, and so on, cryogenic, high temperature, or so on. We would like to have more functionalities to be able to do novel experiments. However, we don't like to change the specimen environment, which would be in practice a new specimen when we are going from one set of analysis to another one. This means we would like to have a platform, or here a cartridge, which has a standardized interface. Maybe all the functionalities would not be present in a single cartridge, but the interface is a standard that it can keep the specimen in the same environment, geometry, and all conditions to be transported to the next experiment or next analysis. Based on this, we are proposing a cartridge in a cartridge solution. This means knowing the uh, available space in electron microscopes and transmission electron microscopes, we might have a smaller cartridge which holds on the specimen, and then a larger cartridge to bring the stimuli close to the specimen. And this cartridge in a cartridge will make the platform that can be transformed by, for example, a UHV or vacuum, high vacuum, or even cryo UHV suitcase to the next lab for the next experiment, or even to the storage place for the storing the sample for sometimes to be able to do the next experiment whenever it's required. Based on this, We are asking in Impress from the companies, from the bidding companies, to design and develop this cartridge in a cartridge solution, which we call it interoperable platform or ECAT, and then which has a standardized interface which can feed to different sample holder, aperture holders of different TEMs from different manufacturers, and then can be transferred via suitcases with different environment of the suitcase to the next lab for the next experiment. And as I mentioned before, it includes TM labs and other communities like beamlines or synchrotrons. To define about the functionalities that we need to define the specification of this interoperable platform via Impress, we have defined different use cases. What is the meaning of the use case? It's quite simple. It's the description of the needs. So what the Impress consortium or procurers would need from companies to provide for the as a design solution and then development from the companies. We have made a full set of documents including 5 use cases, which includes the functional requirement, corrective maintenance, community of users, safety issue, and adaptation. You will receive the full text within the um, OMC document, and after that with all the details in the tender document. However, I'm just going to explain you here briefly what is the meaning or what is the most critical point of each of these use cases. So I will start with the text, but um, you may read it later in the when the document is already published. However, I would like to warn everyone that this might be subject to the changes before the official tender document is published. Maybe with minimized changes, but this is our strategy. Here we have defined 6 hardware requirements, and we are discussing about the functionality as a requirement, not as a specific number. There is no number in this text, or maybe a minor numbering, because all the details will be published in the tender documents at the same time for all companies through the Impress website. The first functionality here, for example, would be atmosphere around the specimen within this platform or inside the cartridge. We may want to work between deep UHV to ambient pressure. And then we know the required atmosphere for the base pressure of, for example, an electron microscope, and what would be possible to reach as an ambient pressure in an electron microscope. There are numbers, and even more important than the numbers, there are procedures how to measure and where to measure for example, each of these functionalities. Here we are talking about temperature, pressure. It could be the same for the temperature, for the electrical contacts, which includes number of standard contacts far beyond the current available designs, and includes also special contacts with special capabilities like high frequency or quite sensitive measurements for in the current or field. The next third hardware requirements include positioning of the specimen, and here again the details you will receive in the tender document, all the details. just briefly speaking, we would like to have a full control about the specimen movement, possibly of one or two microprobes around the specimen, and the next possibility would be some other components which we would like to have a control on their motion. Of course, each of them has its own difficulties or requirement, which will be discussed in the different phases of the PCP after the tender document published. Fourth would be, fifth would be the gas and liquid pipelines uh, for different gas and liquid experiment and environment around the sample to be provided within the cartridge. And the last one would be the consideration of the either fiber optics or free space propagation of the light laser injection for shining the sample or collecting the signals like CL signals from the specimen. An important point here that I should mention, the ideal prototype or which comes from the design of the tenderers might have all of these functionalities. However, due to some difficulties about the space or technological limitations, it is written and it's approved that at least two of the five hardware requirements should be provided in each of the designs solution. So we are not, for example, we're going to have only a very precise cartridge to control the specimen geometry, but not with gas or liquid or without the electrical contacts or without the other capabilities. At least between number 1 and 5, two of them should be provided according to the specification in each solution design, which goes eventually to each prototype. After that, we have hardware requirements. Again, I'm not going to explain all the or read all the text. As you have heard in the Stephan and also Regina's presentation, the whole project is based on openness in the science, and we would like to have APIs for each prototype that provides us not only the basic functionalities of the prototype, but also in a way that we can work on it, integrate it in the host instrument. At the first step would be the host instrument would be a TEM, and the second step could be a SEM or uh, any other instrument in a non-microscopic lab, and to be integrated there, to be automized and remote control and controlled remotely. And this, all the details also about the GUI and interface has been presented, has been listed in the tender documents. The next use case would be the corrective maintenance. What do we mean by corrective maintenance? Indeed, about, this will explain all the requirements about the shipment, installations, test, and service of the prototypes in phase 2 only in Forschungszentrum Jülich, of course, but in phase 3 to other test sites of the IMPRESS project, which I will explain later, will list later. So in practice, everything according to the EU rules and with the requirement from the delivery, installation, acceptance test, service during the operations, and then packing, dismounting, packing, and shipping to the next lab is listed here in this use case. Another important point here for the companies is the fact that it is defined that in phase two, the entrance point would be minimum of 50% of the prototype functionality, which of course will be weighted and evaluated by PCP teams within the Impress. And then at the end of this phase, we would expect to have at least minimum of 80% of the functionalities. And when we go to the phase three, we should start from 80 to 8 or 85% of the functionalities, and then hoping to reach the 100% of the functionalities as is listed in the first use case functional requirement. Yeah. The next use case is about the safety issue. In principle, many of the companies, even from US or non-European companies, also have experience work with European labs and deliver something to them. Everything would go based on the CE declaration and the rules which are operating in EU. Again, all the details has been explained in the documents, but in general, the most important point is that the contractors are responsible for providing the safety issue, and in case of a failure, uh, the technology provider or the contractor would be responsible, not any lab in the consortium or not each test site. The next uh, use case is about the community of users, and this is based on the past experience the Impress team has experienced in the community when a product has been purchased and delivered to each of the consortium partner. Here we are trying to we are asking the contractors to develop a community of users, which are not really the customers, but they are all potential customers of the product, of the prototypes at the end of PCP procedure. And what we are asking them to make this community to make a kind of membership rules from academia and also some industries, and then with following the rules of the IPR, confidentially of the project, and so on, and governance structure and voting rules according to the following term that you can see here. The community of users would have, we are asking them to have at least 2 meetings per year in one of the sites in the EU. Of course, this meeting could be hybrid, but it should be hybrid. It cannot be online, and the other meetings could be also online for this to share the experiences, share the achievements, and collect the suggestions for improvement of the prototypes to reaching, for example, to TRL9 and so on, and also to make a better understanding between the users of these prototypes or potential future customers, how they could operate the devices, how could they have a full control on the devices. Uh, the last use case, which goes basically to the phase three of the PCP, is about the adaptation. What do we mean for the adaptation? Is that at the beginning, as I mentioned before, we work with TEMs, and we are trying to co-develop together with the companies some prototypes which with next level of functionalities for different TEMs. In the third phase, these prototypes or this cartridge solution should be transformed to the other communities other than TEM to be tested there and run the experiment there, correlative experiment on identical specimens. And for this, definitely there might be some needs for adaptation. The simplest one, for example, could be the spot the required visible area around the specimen, which in TEM is quite localized and limited, but the other disciplines may need much larger specimen for making a measurement due to the larger probe size. And this would be in the third phase of the PCP. Now, at the end of my presentation, I will come back to the test sites that we explained before. As you heard in the first introduction, there are 7 procurers in the Impress. Jülich, Forschungszentrum Jülich would be the main procurer, which will carry all the tests in the phase 2. After that, we have 6 different procurers from different countries in Europe, number 2 to 7 here, which are also procurers inside Impress, and definitely they are contributing in the design, discussion, preparation of tender documents, and also evaluation and testing of the prototypes, and making decision for each test, for each phase of the PCP. And 2 additional labs in Paris and Maastricht for running unique experiment in these labs, and in total we have defined 9 test sites. So again, it's critical knowledge. In phase 2, all prototypes will be shipped only to Forschungszentrum Jülich. In phase 3, each of these 8 prototypes might be tested in 1 or 2 or 3 of these test sites, which has been listed here. And according to the use case of corrective maintenance, as I explained before, we expect the companies to take care of the shipment, handling, mount, installation, dismounting, and safety issues of the testing the prototypes in each of these test sites. By this, I will come to the end of my presentation and would like to thank you all of you for your attention. And then maybe I can pass the thing to Rafal, to Regina to continue.
So thank you very much, Amir. So I now leave the floor to Rafal Dunin-Borkowski for his presentation on user and bidder feedback.
Okay, thank you, Regina, Stephan, and Amir. So as you heard from, first of all, Regina, we have a very disruptive project, which is labeled Impress, which is based on an interoperable platform. And Regina described some of the scientific work packages and also other concepts such as the Open Knowledge and Innovation Hub. And Stephan described some of the legal and administrative aspects of the pre-commercial procurement procedure, which has involved a market analysis, a business case, and which will move towards an evaluation of tenders. And Amir described some of the technical aspects of the pre-commercial procurement process itself from the perspective of the execution of the contract. And this involves a number of phases that include a solution design phase, a prototype phase, and then validation and demonstration, execution, integration, and validation. But throughout all of these presentations, one of the main points that was emphasized was the need for feedback and input from end users and from bidders for the contract. And the key concept here was the open market consultation. So first of all, from the perspective of end users, TEM users and also other users of the interoperable platform within the framework of the open market consultation are invited to share their needs and their requirements for the desired solutions for the interoperable platform, not only within TEM columns, but also linking to benchtop experiments and other analytical tools. On this slide, there is a link to a survey and a QR code where end users are encouraged to provide their feedback and input to the project. This open market consultation has already begun, and we have received a number of items of feedback in responses from end users. And these are end users not only based in Europe, where the project is funded, but also from around the world. In particular, academic organizations from both Europe and America in particular, as well as research infrastructures, and also companies have provided us with feedback already. And this includes users who work in both material science and life science, and users who work both in instrumentation development and as operators of electron microscopes and related tools. From the first feedback that we've received, and also from personal discussions with end users, it is clear that the IMPRESS project responds to a very clear need. First of all, there is a need to improve hardware and software to develop novel concepts in electron microscopy and to develop correlative workflows. And there is also a need to develop interdisciplinary, cross-technique approaches which link electron microscopy with other analytical techniques through an interoperable concept, which is the primary concept in the IMPRESS project. In other words, there is a need for open solutions and for innovation, linking together academic users with innovative companies. This is the feedback from users, but what is equally important is the feedback and the questions from the bidders for the contract. And here, technology vendors are, again within the framework of the open market consultation, invited to ask questions. There is an open market consultation questionnaire, and there is a link to this questionnaire on this slide together with the QR code. The answers to all of the questions from the bidders will be published in the findings of the open market consultation, which finishes in September 2023, and also on the website of the IMPRESS project, e-impress.eu. Another point which we have already made is that in order to ensure fair competition, all of the questions will be answered through the open market consultation questionnaire rather than through direct contact with the companies. Another part of the open market consultation is an in-person and hybrid meeting, which will be held in Düsseldorf later this year. And for any bidders who would like to find out more about the pre-commercial procurement procedure or to ask any further questions, the bidders are encouraged in particular to attend this event in person in Düsseldorf. There is a link and a QR code on this page. For any bidders who are not able to come in person, the meeting will also be held in hybrid form. However, in-person participation is very strongly encouraged. And so just as a few slides to summarize the presentations that we've heard today. In a nutshell, the Impress project aims to develop an interoperable platform through a pre-commercial procurement procedure which has 3 clear phases. These phases will be open to companies or alliances of companies. There will be a primary test site, which is the Forschungszentrum Jülich, but there will be other test sites for the prototypes that will be developed during the pre-commercial procurement procedure. But ultimately, the outcome of the project is a set of interchangeable hardware and software components based on standardized concepts, which will link together different tools, not only electron microscopes from different companies, but also preparation tools and other analytical techniques in as open a manner as possible, but at the same time providing additional business opportunities to the companies that will be participating in the project. As we also heard, the pre-commercial procurement process, which is an integral part of the project, has a budget associated with it, and there will be a certain number of contractors and a certain budget allocated to each phase of the pre-commercial procurement process. And Stephan Corvers has outlined many of the logistical, legal, and administrative aspects of this procedure, and Amir Tavabi has outlined many of the technical aspects about which any potential bidders are welcome to obtain more information in the next phases of the project. With this summary, I would like to encourage anyone who has not already participated in the open market consultation from either a user or a bidder perspective to ask us as many questions as possible. And as we mentioned, the open market consultation finishes in September 2023. I would also like to encourage again any of the bidders to attend the Düsseldorf event later this year in person. With that, I would like to finish my presentation and thank you very much for your attention.